Hello. Привет, товарищ. Yeah, I'll just take a photo because I never take photos. And then my company is like, you went to, somewhere and you didn't take a photo. So I had to do that, okay? Hello. My name is Maciej Mensfeld. I'm a software engineer, creator of a framework Kafka, and an open source contributor. So I basically do stuff for free, and people expect me to fix it fast. Now? Is it better? Okay, sorry. Is it fine? Okay. I work for Castle. Castle is a company that handles like web security. We do account takeover mitigation detection. It's my first time here. And this city is awesome. I would use a word on F, but I shouldn't. So it is awesome, amazing city. But funny thing, what Mariam mailed me with an invitation, I thought that it's like the dating scam, you know? So I was like, what the hell is it? So I asked this guy, because we share an office, is it legit or is it a dating scam? And he was just like, it's true, go, 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 go. You'll drink a lot. I hope. I'm also a Krakow Ruby user group organizer. It's one of the biggest communities, local communities in the world. You're always invited to Krakow. We meet on a monthly basis, and yeah, we have a lot of fun and good technical talks. Always two good technical talks. And yeah, I'm founder of this funny framework, but I'm not going to talk about it today. Because I have workshops tomorrow on it. So if you're like interested in doing some batch processing, in memory computation, streaming, stuff like that, if there are free spots, just apply for them. If not, you can catch me somewhere here later, and we can just discuss stuff. You can always mail me if you have any questions, and I blog from time to time here. Mostly on engineering and architecture. And you can talk with me about literally anything. I do a lot of dry RB stuff. I did some commercial implementations with Trailblazer, so I have bad and good things to say about it, and Nick. I did a lot of bad things with TCP as well directly. So yeah, I think it's funny. And if I speak too fast and you want to ask something, I'll just do. What I hope to leave you with is the feeling that you can do something with Ruby outside of Rails, and that there's a whole universe that it's worth exploring, because it can solve many problems without introducing too many new. I'll quickly go about problems we had. Some details on SLAs and how you can have them in internal systems. What is druby? Why you shouldn't use it. And some details on how to build fast stuff. And I'll have some simplifications, because obviously we have half an hour. And yeah, it will just be the tip of the iceberg. So I work in this company. It's a nice company. We're not hiring, not like all of the companies that are here, including Cookpad. Hello. A really nice office, that's true. I've been there. So basically, we just detect account mitigations. Long story short, we track a lot of data on a daily basis, and we flush it into our systems. So basically, we just like track behaviors and other factors. And yeah, now it's more than 120 million events per day. Yeah, 20 million active daily users. Now it's 100 million active users overall, and around 3 million failed logins. And all of it would be really nice if we could process this asynchronously. But unfortunately, sometimes you can, sometimes you cannot. About async, I hope you've seen this guy talking. His talk was really nice. Both, I hope, here, because it was nice in Japan. But the problem is that quite often you'll have something that needs to be synchronous. Or technically it could not be synchronous, but you have customers and they expect a reply, which is the biggest problem, right? If you wouldn't have customers, there wouldn't be a problem. Especially for a technical system, like we integrate with developers from many technologies, and we provide some SDKs, but from time to time, customers do custom implementations based on our APIs, because obviously you cannot cover all of the technologies. And the same applies, to be honest, for the internal services. So some of them should remain synchronous. Or do they? But yeah, sometimes it's just like that. And we'll try to tackle this problem. So we have a database that is now 4 billion records large, which is it's okay. Not too small, not too big. You can work with it. It's really important that it's not crucial. I mean, it's crucial, but it's not mission critical, which means that if it fails, nothing else should fail in the system. It should be cheap, because AWS is kind of expensive, so the less you do, the less you pay. Plus the overhead of DevOps and other things that people usually don't include, that adds up to a cost. And it should obey some internal SLAs. And yeah, how much is 100 million requests from the description of my talk? It's only 1,200 requests per second, so it's nothing special, really. But it kind of is if you do it with Ruby. So we had this idea of building a service that you would provide an email, and you would get details on whether this email password and login has leaked somewhere in the internet, because we track it and monitor it. It should always respond in a certain time frame, because we have external SLAs for our customers. So, for example, we cannot exceed 200 milliseconds within a request that will have a response. So, you're not supposed to respond for a second or something like that. Yeah, it should be cheap. So the less load balancing, the less instances, the less problems. And it should just have a versioning, just to keep track of the current versions. So the first idea was kind of simple. Let's do it with HTTP. Yeah, it won't happen. You have a new connection for TCP, you can use connection pooling, but it doesn't exactly work on a scale that nice. For Ruby, it works for different technologies, not for us. It has an overhead because it's like text protocol built on top TCP that adds up a lot of headers and other requirements that we didn't want to care about. It was supposed to be a microservice, which is a single functionality, isolated thing. It was supposed to have an SLA, which means that within a company we agree to obey certain rules in which this piece of software should work, including timeouts, stuff like that. And it's actually really good because it allows you to build systems that are way less fragile. And there's a downside to it. You need to have a team that actually understands the importance of certain components that you're building and how they should behave in the whole ecosystem of the actual product. So I thought, why not druby? Please raise your hands if you know druby. What is druby? Yeah, distributed Ruby. Yeah, it's one of the things from standard Ruby library. It is built in Ruby. So it is actually based on TCP sockets. You can just do something like RPC directly with Ruby. So that's first idea, why not? It's super easy. It will just build up the client. You'll just invoke remote calls. And it's like with Ruby, so magic happens behind the scenes. It is super fancy. It is forwarding method calls, building instances, doing a lot of stuff, and actually not garbage collecting, which, if you don't remember about it, is kind of problematic, because on one side, you could just destroy the object and the reference would still be there on the client. It works. It allows actual distribution. You could do some failover, and it's Ruby. So it's awesome and not awesome because you're not able to replace it or build customers for other things. But just to show you guys, it's super simple. You just spin up a host and you just run it. And you do the same on the client. And like magic happens, it just works. It is synchronous, it works, it is simple, and it is blazing fast to do. But it sucks. It actually sucks because no one knows about it. There are a lot of uncertainties in it. It's not explicit, so actually if you're new to the team, you might not realize that it's being remotely executed. There is no documentation. There are no details on scalability, load balancing, or nothing else. It uses marshalling, and it's a bit slow, it's like 10 milliseconds. And the biggest problem, you don't have a control over sockets. So actually what I did, I mailed the author of this library and an author of a book, because they have a book on it in Japan. The guy is called Seki, so I tweeted him, like, Seki, timeouts, TCP, monkey patch. Please monkey patch, right? So he even offered to monkey patch that for me, but it doesn't do the job because it wasn't built to support that, so I would have so many problems with it that I just decided to drop it. Yeah, there's a book on it. And actually, it's a funny thing, I bought this book. When I say Japan, I don't speak Japanese, so I was just looking at the code fragments, and there's a whole section on how to use it with Rails to speed up templates rendering. It's just crazy. And they do that. I hope they don't, but they do. So yeah, so the next idea was that I could just put it in the code base and make it work directly from the code. But no. So I decided with outside service that would allow me to isolate things. It was a separate context, so it was really nice to just have it outside. It could be way more memory efficient than spinning it up in every single Puma process, Sidekick, whatever. I could reuse it, and I could just have a thin client that would work. So if you decide to do something like that, despite whether it's sync or async, you'll deal with many problems, a lot of timeouts, partial data in Linux sockets, Linux-specific things, if you want it to be performant, like priorities, schedulers, stuff like that, and just handling failovers, connections, disconnections, things that usually you don't think about, like signals, terminating things, exceptions, building actual libraries around to instrument things so you know how it behaves, because if you don't know how it behaves, you won't measure it. Limitations, rejections, the biggest problem for me it is load balancing, and there is almost no documentation on TCP in English for Ruby. There are actually Ruby bugs related to that I've reported, but I'll get back to that later. So the initial idea you could try is building a thread-based server. It's fine, you spin up a server, a couple lines of code, and you just wait, and it works. Nice stuff. That is kind of, I have 2 slides with the same thing. That's okay. One thing, just a digression. Apps should live in a VM, so I should be also able to just start and stop them and restart them without doing that to the Ruby process. Ruby process should be just a virtual machine in which I execute my business. So it would be nice to have something that is actually just a frame in which I can operate. To do that, you'll have to have a client, you'll have to have a supervisor that is actually keeping your code monitored, and if it misbehaves, it does something to it. There's a server, something that manages the connections handling, and user code, and you can do it by yourself, and it's great if you have less than 100 concurrent connections. You control everything, so all the bugs are yours, except Ruby. You can add anything you want, it's memory efficient, and it's not worth it. Don't do that. Please don't do that. There are many libraries like Event Machine. I've seen a talk here. I didn't attend it, unfortunately, but I saw that there is. So I work with event machine, but any library like that is fine. If you don't know, it's just event-driven I/O library for Ruby with a reactor pattern. And just briefly for people that didn't attend, reactor pattern is used, for example, Node.js as well. So we have a single thread that is responsible for accepting connections and sending the messages outside. And you're not supposed to do any slow or heavy workload within the reactor thread. It is battle tested. I think it does not include IPv6, but we use it internally, so I don't mind. It is suited for systems with a lot of connections, especially if you use epoll on Linux and things like that. And it has sync and async support. And it allows you to manage sockets, which is really important. So just an example, a couple lines of code. You start it, and then it works. And you can actually change stuff on the sockets. All of this is undocumented. And when I was in Japan, I was having a drink with some of the Japanese people that work with Ruby documentation and core Ruby parts. So I asked one of them, why isn't it documented in English? And he was like, no, Maciek. It's not documented in any language. But you can Google that, and actually there is some docs on other languages or for Linux directly, because those are inherited from Linux. Or TCP docs actually for any language. There is the problem of Ruby not having proper timeouts support. So we actually just bypass that by using something called IO select that will just rise the timeout, which is super interesting because it won't, but I'll get to that later. And there's Nagel's algorithm that is super problematic if you have a lot of really small connections that need to be really fast, because what TCP is doing under the hood on Linux, it's buffering small messages, because the cost of sending TCP message can be actually bigger than the payload. So Linux is squashing that all together and sending it at once. And if you have it, your system might get significantly slower because of that. Especially including acknowledgement, because it's TCP. But you can disable that, and it works. But it creates an overhead, and you want it to be fast. And it can be really fast. You can process, this is like a 1/10 of a millisecond. To just actually do some business logic, this is how fast our system replies and sends the data. So this is on the server side. There's plus the TCP overhead, so it adds up to 2 to 5 milliseconds per the whole cycle. And yeah, so the average and the max. So this is actually what you can easily achieve with event machine. With certain timeouts, if you add SLAs, sometimes it will just drop connections because it won't wait for them. It's super important to instrument things like that. If you work with Kafka, it's exactly the same. Just instrument everything, because it's super important to understand how your system behaves, because sometimes it starts misbehaving actually without reason from your side. And yeah, just a lot of requests to a single Ruby server. Funny thing is, if you use event machine or any other thing, and you build something like that, you can put it into screen, and it actually works for a couple months, and no one notices that it's in screen, without proper DevOps stuff, and it actually works. But there are a couple problems. There is DNS resolving performance problem. So if you have slow DNS, it impacts the system, and you're actually unable to control that directly from Ruby without rebuilding the socket stuff. There is the network overhead. You have random CPU spikes on Linux because it decides to do other things. You have different Linux kernel schedulers that can have impact on your software, processes, priorities, and something I called randomness. I don't know what it is. It's just on AWS. I was Googling a lot, and I found some articles that if you see performance dropdowns, and you didn't change anything, you might try building a new virtual machine because the previous one might be on an actual hardware that is heavily occupied, and it will, like, the penalty will leak to your systems. But let's assume you've built something and it works. You've tested it, and it hits production, right? So you have a server, you have a client, you're quite sure that it will work. Works for staging, you have timeouts, you've tested all of it. It's not hard, theoretically, because you put it just a timeout, and it obeys all the limits. And you deploy it, and everything works till a Saturday. A certain Saturday, couple months later. It's like you didn't change anything. Everything used to work, and then boom. You know, like the average time of requests goes to like 300 milliseconds, and you set it to 10 milliseconds. So after 10 milliseconds, it should be terminated because it's too slow. And that's like 300 milliseconds, right? All the requests are being dropped, and actually the server stops processing messages. So what the hell is going on? You didn't deploy anything. No one did any changes to the infrastructure. We have it in Terraform, so it's just easy to check. Nothing happened. It's Saturday night. My wife is extremely pissed for me sitting in front of the computer and just, not understanding my own code because I've built that. And then it turns out it's a Ruby bug. An amazing Ruby bug that is actually present in all of your software. For HTTP, anything that is TCP-based, all of it has this bug. I just confirmed that in JRuby it's the same. So it applies. It probably applies also for Truffle. And it's a super interesting bug. I have still 5 minutes, right? Is someone monitoring the time? OK, so you set a timeout, 50 milliseconds. And you try to connect to a server, and it's 50 milliseconds. And what happens? You should get a timeout. You won't. You won't. What will actually happen, it won't do nothing. You will just wait, like 5 times longer or something, depends. So, it's a Ruby bug. So let's look into the Ruby code, actually, and let's fix it. I mean, why not? So this is like a bigger part of TCP connection implementation that includes this bug. It's a loop. It's a simple loop. It will just try to connect with a timeout. And if it doesn't work, it will next. What does it mean? It actually means one thing. If you set a timeout to 100 milliseconds, but your domain address resolves to multiple IPs, which is totally valid. Like, we do it all the time. And you have like a single IP that is being resolved to 10 addresses, your timeout gets multiplied. So instead, you set a 100 milliseconds, and you wait a second. You set it to 20 milliseconds, you wait 200 milliseconds. And it's like, oh, but we have an SLA. We need to deliver the content in 200 milliseconds. So we set a timeout to 10 milliseconds, and it should just rather throw this data away. No, next. And if you have a load balancer that is actually keeping the connections while there is nothing behind it, because it's hoping that it will restart, it will actually cause this problem. It will just multiply things. Can it be fixed? Yes. So I've submitted a bug request. No one replied in 2 months. I've even commented that I can fix that. I'm willing to fix that. I will fix that. I'll submit a patch with specs. 2 months, silence. So Aaron is here. And yesterday I was like, Aaron, why do you guys don't reply to my bug report? And he was, don't get me started. It remained unreplied, but I forced him. So we had a discussion, and I'm actually going to fix that. So sometimes the problem may not lie in your code. And actually, it's not this guy's fault. It's been there for a while. but most of the time, people resolve domains to a single IP, and there's no problem with it then because it works exactly as expected. But the behavior outside factors shouldn't impact the way this code is being executed. But actually, if you think about things like that, you can build better stuff by just making it async. So instead of just calling things one after another in an async way, 10 minutes? OK. Or it's half an hour, so including questions, right? OK. I'll finish soon, so. You could switch it around, and you could just use the fact that Ruby has like green threads and giant interpreter log, global interpreter log, but it is not I/O bounded. And it means that you can perform I/O operations, and something else in Ruby will be executed. So what you can do, actually, you can build microservices, which you will ping. Then you will do some synchronous stuff you need to do, like saving things to database or other things. And you can try after that fetching the results back. And if they are there, it's fine. If they're not there, well, you should be designing systems that can handle failover. If you're not having a failover in your system, apart from like the master process, the master flow, you're doing something wrong. And it's really bad. And if you design things in a way like that, so just request data, do something else, try to get it back, and do something else, you can, first of all, drastically shorten the time of execution of request or processing. You can scale much easier because you delegate workload to different processes, and it's Ruby, so unless you use JRuby, which you should. But if you do this like that, you're back here, and you're back into Anton's world. So you can have parallel execution. You're not bounded to I/O. You can have SLAs, assuming you've patched this bug for Ruby. And you can achieve performance that is less than 5 milliseconds, because actually, if you think about it, and you delegate this work, and you don't wait for the result, but you actually just check it after doing other things, it is instant, or it is not there at all. You can use Event Machine or other libraries. I just use Event Machine because I'm lazy, and I use it a lot. And I know how to fix problems and bugs that exist in this particular library. But it's the same for other. Anyhow, you'll have to deal with all the sync problems if you do it async, which is timeouts, partial data, things like that. But still, isolate, play, experiment, and monitor. For Rails, there is active support instrumentation, I think. You can take dry monitor. They're API compatible. So actually, you can just replace them. If you use something like dependency injection, you actually don't have to care about what particular library is it. You can just replace them. Put it on production and hope that there aren't many new Ruby bugs in all of it. Thank you. Any questions?
Ребят, вопросы? Секунду.
Thank you, Maciej, for the speak. Why Kafka?
Well, come to my workshops tomorrow.
Of course, I will go to your workshop tomorrow, but why?
Well, it's a funny thing, because the first reason was not mine. We had a decision whether we should go with RabbitMQ, ZeroMQ, or Kafka. At that point, it was 5 years.
So you came to the Redis stack.
It was
to accommodate.
5 years ago. And I went to our DevOps at that time, and I asked, Łukasz, if I give you those technologies, which one of them will you want to maintain for the same salary? And he was like, yeah, I'm going with Kafka. So this was the first reason. And at that point, ZeroMQ didn't have broadcasting. RabbitMQ didn't have broadcasting. And for me, for event-driven design, for asynchronous work, broadcasting and batch processing is actually those are actually the two most important things that you need to have performant systems. If you end up with consuming single messages without broadcasting and just piping them down, like single messages.
Do you do event queues?
Yeah, you're unable to do that. If you flush stuff into Kafka in batches using async producers, you can flush thousands of messages per second, even more, and you can just read the same. Like, it's not Kafka talk, but Kafka handles 55 to 60,000 messages per second. So try designing your part of the software that will utilize this speed, right? And yeah, that's all, basically. Long story short.
Thank you, thank you.
Thank you. See you at the workshops tomorrow. They're not going to be about TCP.
Да, ребят, на сайте еще есть, по-моему, 5 мест на воркшоп Мачея завтра, поэтому прямо сейчас доставайте телефоны.
Еще у кого есть вопросы? Тогда, я думаю, мы должны поблагодарить накладчика. Спасибо большое. Thank you very much. Thank you.